All right, good day, everyone. You can see your quote friendly reminders on this file. And this will be our last discussion together. So if you're Tuesday, Thursday student, then this will be our, like I already said, this will be our last meeting. Thursday, May 7th is going to be your last day to take your final exam. There are a couple reviews set up in that last folder for the final exam, the chapter-based. They are not mandatory, but they are recommended to complete because they're going to be content refresher that's relevant to the test. So we, of course, suggest that you do them, those of you who are keeping up with the work. And then your final exams are due no later than 11:59 p.m. May 7th. If you're in my Monday, Wednesday class, then our last class is Monday, May 11th. Now, this is still going to be our last meeting, which counts as Wednesday, May 6th. But then you have Monday to do the test. And the reason I'm not doing a lecture on the last day is because if we were meeting in class, I would not be lecturing on the day that you take a test. I don't think that's fair. So I don't want to do that. I want to make sure that you have enough time just in case you need this hour and 15 minutes in order to take the test. Maybe you've got other things in your schedule. So the last day to take your final again for the Monday, Wednesday class is Monday, May 11th. This is based on whether you're Tuesday, Thursday, or Monday, Wednesday class. It's not just me arbitrarily choosing those dates. And then your finals are due again, May 11th. No class, May 11th, no class, May 7th. This is the last time we will meet. In order to take the final, you got to have 80s on all homeworks and quizzes, 75s on all previous tests. In order to pass this class overall, you have to get a 70 on the final. You only get 2 attempts on the final exam. You are allowed a calculator. You are allowed your formula sheet, which you can print or just have up on a PDF. And then the failing grades that you might see, coughing bad this morning, sorry, is an R. Means if you get an R, means you pass the first 2 tests, but not the final. If you got a U, it means you did not pass up to and including test 2. So you may have done all the homeworks but never taken a test. You're going to get a U. You may have done all the homeworks for chapter 1 and the test, all the homeworks for chapter 2, but didn't take test 2, part B. Passed A, but not B, you're going to get a U. As long as you pass test 1 and then both parts of test 2, you get an R for failing. And again, there isn't a real difference between an R and a U, except just as documentation letting us know how far you got. This is something that was used just for tracking that I don't know if it's really going to be an issue anymore, considering that we're changing formats in the fall to these MDE courses, MDE 10 and MDE 60. So this class is basically going to become MDE 10, and then the rest of the developmental maths become MDE 60. This is just something that happens every 2 or 3 years at TCC pretty regularly, and if you asked my opinion on whether it would happen again, well, you might be able to guess based on the tone of my voice. So, you know, it's just how we do things around here, whether we like it or not, whether it makes sense or not, it's how it's done, and we roll with the punches, and we do our best, right? Okay, so that being said, if you pass this class, it doesn't really affect you. If you fail this class, I don't think it will really affect you. It just means you'll be taking a different name for a similar, very similar course later. All right, so we've done the review for chapter 1, we've done the review for chapter 2. We're going to go a little quicker through the review for chapter 3, since this is the freshest material. What's happening? There we go. And also a lot of these sections were just kind of shorter and more compressed, I would say, overall. So we learned about exponents and square roots. Honestly, you had already seen exponents before. Something like 2 to the third was 2 times 2 times 2. The base is repeated, and the exponent tells you how many times to repeat for exponents. And then for square roots, trying to find a number that multiplied by itself makes the inside number. Number. There we go. Example 1. Was I continuing with new examples in each chapter? Yes, I was. Good. That's what I thought. Here we go. Here we go. So for example 1, we're going to evaluate. I'm just going to do a couple of these. In fact, I'll do 2 to the third since we mentioned it. That would be 2 times 2 times 2, which is 8. And then if we had the square root of 25, this would be 5. And that's because, or since, 5 times 5 is 25. That second problem, that square root, is called an implicit problem because you can't just look at it and know the answer. You have to kind of play with numbers in your head or have them memorized in order to get the answer. Whereas 2 cubed, there's no memorization. It's you just process. The processing of square root of 25 means you've got the answer and you're wondering what the question was, kind of a situation. Now, we saw problems where we had to just write in an expanded format. So if I said to expand this, then you'd be writing the 2 times 2 times 2. If I said to write this in exponential notation, you'd be writing this as 2 cubed. We had all those different little details in how to write the answers. And we said to make sure that you're paying attention because the format is important. You get it wrong. If they ask you to expand and you write 8, they're going to want 2 times 2 times 2. If they give you the problem 2 times 2 times 2 and you write 8, but they ask for the exponential notation of it, that's going to be wrong. So make sure that you understand what to do in which situation. All right. I mean, that was pretty much all of 3.1. Then we had sign numbers and their math, their arithmetic. Hold on. All right, first of all, we said the absolute value of a number makes it positive no matter what. But then a small little note, just because you see an absolute value does not mean the answer is positive because there can be negatives outside. So watch out for that. We saw examples with that in class. The opposite of a number changes the sign. We had classifications of numbers. We said the rational numbers are fractions or terminating repeating decimals. Terminating or repeating, one or the other, can't be both. Irrational numbers are the opposite of that. So can't be written as fractions, can't be written as terminating or repeating decimals. These are typically pi and square roots we don't know. So if I ask you to classify the square root of 4, that's rational because we know it, it's 2. If I ask you to classify the square root of 5, it's irrational because we don't know it. It's something like 2 point blah, 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 and there's no pattern to that blah, blah, blah. All right. Adding and subtracting. Sign numbers. First of all, if it's subtraction, comma, change to addition and change the sign of the number that was after the subtraction. Once it's addition, or if it was addition to begin with, it was same sign, add the numbers, keep the sign, or different signs, subtract the numbers, keep the larger numbers sign. And I have larger in quotes because I mean larger in absolute. And then I'm capitalizing the important letters, same, add, keep, or different, subtract, larger. So those abbreviations were SAK and DSL, if you like the abbreviations. If you don't, then don't use them. For multiplying or dividing sign numbers, if they're the same sign, the answer is positive. Or if they're opposite signs, the answer is negative. And the abbreviations for this weren't as fun by themselves, SP and ON, or you could just put them together to form a word, spawn, like spontaneous. It's like a word abbreviation. And like I said, not everybody likes these uses of single letters to remember things. Some people do. I'm giving you options in how to do things. You can memorize statements, you can memorize it by doing it 10,000 times, or you can memorize abbreviations. It's up to you. But what you have to do is practice this stuff. Don't expect to do these 3 or 4 times and be done with it. It doesn't work for anybody. I don't think y'all get enough homework personally, and I know it's probably an unpopular opinion among students, but you should probably be doing 40 or 50 of these in each assignment. I find that people just do better on average with lots and lots of repetition that we're not forcing on people anymore, and I'm ranting, so let me get to the point. Example 2. Point being, do more problems if you don't feel confident in your work. Why did it switch to blue? I never hit blue. Word does some weird things sometimes. Simplify, evaluate, whatever. So let's do 10 plus negative 12. These would be different signs, so we're going to subtract and keep the sign of the larger. When I say subtract, I mean take the bigger minus smaller when we're thinking absolute. So 12 minus 10. 12 minus 10 is 2. This was DSL, if you like my abbreviations. But the larger number was negative, again, larger in absolute, which is this should be a negative. Different signs, positive, negative, subtract, keep the sign of the larger. That's it. What about if I had 10 times negative 12? Well, this is a multiplication rule. It's not SAK and DSL, it's SPON. Same positive, opposite, negative. Well, these are opposite signs, a positive 10 and a negative 12, so the answer should be negative. And 10 times 12 is 120. Now, you are allowed a calculator for doing problems like this for the final exam, and I detest that. You should be able to do this without a calculator. If you can't, you are going to have problems when you move forward in math. All right, rant, I know. How about, ooh, that was an oopsies, 10 minus negative 12. Well, that's a subtraction. The typical way we handle these is we think of them as adding the opposite of the number seen. So this is 10, we change that to a plus, and then instead of a negative 12, it's a positive 12 now. And then if you want, you can write the rule, but most people just kind of add at this point. 10 plus 12 is 20, sorry, 22. Same, positive, positive, add them, keep the sign, and there's our answer. Sorry about this. All right. Let's do negative 10 minus 12. Well, it's another subtraction, so we need to change it to negative 10 plus negative 12, adding the opposite sign. Now this negative 10 and negative 12, that's the same sign, so we're adding and keeping the sign. 10 plus 12 is 22 again, but they're both negative, so the answer is negative. Same add, keep, different subtract, larger. Let's work with a new number. Let's do negative 10 times negative 11. I like the 10 right now. I don't know why. All right, so this is multiplication. So we're not using SAK or DSL, we're using SPON. These are the same sign, so the answer should be positive. 10 times 11 is 110, and that's it. So again, SP. This one back here was ON. And we'll do a division for good measure. Let's keep it simple. Negative 18 divided by 2. Some people think that the order of the signs matters. It doesn't. For adding and subtracting, it's all about which one's larger if they're not the same sign. Multiplying and dividing, it's just whether they're the same or opposite if you're dealing with pairs. Well, 18 divided by 2 is 9. That's a negative and a positive, so these are opposite signs, so the result should be negative, so negative 9. And there we go. Now, you can see these applied to fractions. You can see these applied to decimals. It doesn't change anything in terms of the sign rules. Now, I've also mentioned that when you go to your next math class, your professors are likely not going to do these changeovers. They're likely not going to write negative 10 minus 12 as negative 10 plus negative 12. They're probably just going to go to the answer as negative 22. So you need to practice and understand this enough that if you don't see this middle step, you can still go from the beginning to the end, and you can always show that work on your own. But when we start dealing with variables like we did, we just typically don't do these rewrites 100% of the time moving forward. We like to think that it's implicit in our minds. All right, so moving on. Properties of numbers. We had the commutative, and this is where for addition and multiplication. And I'm not going to write out the A plus B equals B plus A part. We've seen that, or A times B equals B times A part. I'm just going to say the order doesn't matter for several additions or multiplications. Multiplications, there we go. Now, I'm not saying additions and multiplications. I'm saying a bunch of additions or a bunch of multiplications. 5 plus 7 is 12. 7 plus 5 is 12. The order I add them doesn't matter. 2 plus 3 plus 4. 2 plus 3 is 5. 5 plus 4 is 9. Okay, add them in any order you like. It won't matter. 4 plus 3 is 7. 7 plus 2 is 9. Or if I'm multiplying, 2 times 3 times 4. 2 times 3 is 6. 6 times 4 is 24. Or I could do the 3 times the 4, which is 12, then times the 2, which is 24. You get the same thing. But it's just if you're adding or multiplying, you can reverse the order of the additions and it doesn't matter. The associative property I don't need to say property, the associative property of, in the same thing, addition and multiplication only. So these things don't work for subtraction because the order of subtraction does matter, or division because the order of division does matter. But same thing here, it just says that you can group additions or multiplications however you like, as long as it's just that one type of operation. I'm not saying you can add and multiply in whatever order you like. I'm saying you can, if you see a bunch of additions, you can add them in any order you like. If you see a bunch of multiplications, you can add them in any order you like. Then we had the distributive property, which I will write out. That was A times B plus C is equal to AB plus BC, which just means you multiply everything on the outside to everything on the inside. That's what the distributive property means. And that's the only one we really kind of emphasized on pencil and paper, but we did, again, verbally talk about those first two properties extensively on and off throughout the semester. I would show that it didn't matter that the order we added or multiplied. But again, PEMDAS, order of operations, when you're mixing and matching things, that's when it starts mattering. Subtractions, it always matters. Divisions, it always matters. Additions and subtractions play a little looser. All right, so let's try out one of these. Example 3. Let's go simplify or distribute, whatever you want to say. So let's say we had 5 times 2x plus 7. So normally what you do with order of operations is you try and combine the inside of the parentheses, p first, then you handled the multiplication of the 5. But the problem is these are not like terms, so you can't combine the inside. Like terms have to have the same variables or no variable at all. So because you can't combine the inside, we distribute instead. We take the 5 times the 2x plus the 5 times the 7. Now 5 times 2 times x, we can multiply in any order we like. We know how to do 5 times 2, it's 10, but we don't know how to do 10 times x, so we leave it alone. And then plus, so 5 times 7 is 35. That's as much as we can do because those are not like terms. Once again, one of them has an x and the other does not. So there's your reminder of what like terms are. They have matching variables and exponents. We've discussed the difference between expressions versus equations. Expressions are to be simplified or evaluated and contain no equal sign in the original problem. Equations are to be solved or checked in general, and these are not the only two things you can do for them. There are lots of other analyses you can do, but this is all we do in his class. So they can be solved or checked and have an equal sign built in. So there's a left and right side. Simplifying expressions, you just combine like terms and or apply the distributive property. Solving equations, your goal is to isolate the variable. I can spell, I promise, sometimes. By working in opposite operations. And then we said addition and subtraction are opposite operations. Multiplication and division are opposite operations. That's really weird how sometimes it's That's really weird how sometimes it's, when I hit enter, it gives me one line and sometimes it gives me two. Whatever, doesn't matter. So if you see an addition, you subtract. If you see a multiplication, you divide, and vice versa. And you want to pay attention to the side with your variable. Now, you can move variable terms from side to side as well. That is not anything that we did in this course, but you will see it in your next math course, I guarantee it. All right, so after the distributive property, we had example 3. Now we're up to example 4. We'll simplify for example 4. And let's just do 7 parentheses 2x plus 3 minus 4 parentheses 5x minus 1 plus 10. So distribute and combine like terms. That's what we need to do. And you might say, oh, the like terms. We got a 2x and a 5x and then a 3, a 1, and a 10. Arguably true. but they're all inside different parentheses or outside, so we can't really play with them right now. We can't combine them. We need to distribute first. Distributing the 7 times the 2x, and I will write everything out for this one, then plus the 7 times the 3. Then we're distributing the -4, so that's going to be a -4 times 5x, and then -4 times -1, then the plus 10. There are several different ways to write the signs for the parts with the 4s. I'm not going to go through all the different ways right now. This will give us 14x from the 7 times 2, plus the 21 from the 7 times 3, minus 20x from the 4 times 5, plus, and this is where lots of mistakes are made all over math, that's -4 times -1 is +4, then plus the 10. Now we can combine like terms. 14x minus 20x, that's the same thing as saying 14x plus -20x if you need to do the rewrite, which would be -6x. Different signs, subtract, keep the sign of the larger. Then the 21 plus the 4 is 25. I think that's pretty obvious. But then we have the plus the 10, which is 35. 21 plus 4 is 25, plus 10 is 35. Those are not like terms. You can't combine them. That's our answer. Example 5, we're going to solve. We'll do a couple of these. Let's do x plus 17 equals 39. Let's do -39, in fact. So I only really care about what's on the variable side. I got a little overzealous with my pen right there, but I don't even care what this number is. It doesn't tell me what to do. The plus 17 tells me what to do, so I'm not even looking at that because I see a plus 17 to get it away from the x, because this is an equation, we have to work in opposites. And whatever you do to one side, you do to the other. So to move a plus 17, we need to subtract 17, but I can't just do it on the left, I got to do it on the right as well. So we subtract 17 on both sides, which will give us, we bring down our x, the 17's cancel, -39 minus 17, that's -39 plus -17. Same sign, add the numbers, keep the sign. 9 plus 7 is 16, 3 plus 1 plus 1 is 5. Keep the sign, so that's a -56. And there's our answer, because it says x equals. We have, let's go with 12x equals -12x actually, equals 72. 72. Well, that says 12 times x. Again, I don't need to look at the 72. That doesn't tell me anything. It's the side with the variable that tells us what to do. That says 12 times x, -12 times x. So we divide, because that's the opposite of multiplication. So we got to divide. Now you might just divide by 12, but this is a mistake, because -12 divided by +12 is -1. You have to divide by that sign as well so that they cancel. -12 divided by -12, gone. That just leaves us with our x. And then 72 divided by 12 is going to be 6. A positive divided by negative is a negative. Opposite signs, so negative. So there's our answer. They don't have to be this short. They can be a little longer than this. Yeah, we'll put it over here. Let's go with, I don't know, 13 parentheses x minus 2 minus 12 parentheses x plus 3 equals 5 minus 9. So we are not ready to just move things from side to side because there are distributions, there are like terms, there will be more like terms after we do our distributions. So let's handle the distributions first. So 13 times x is going to be 13x. I'm not going to show the extra step here. Then a minus. 13 times 2 is 26. Now we're distributing a -12 here, so watch your signs. You are distributing a negative. So pay attention. So that's a negative 12 times x, which is a negative 12x. And then negative 12 times positive 3 makes a negative 36. Equals, I'll leave the 5 minus 9 for now. Now let's combine our like terms. 13x minus 12x. This term and this term, they are like. So they'll combine. 13 minus 12 is 1. I'll write the 1, but we won't write it after this step. You don't have to write the 1 at all. So that was this one and this one. They're gone. So now we're stuck with the negative 26 and the negative 36. You need to see that math. That's negative 26 plus negative 36. Same sign, add the numbers, keep the sign. 6 and 6 is 12. 2 plus 3 plus 1 is 6. Keep the sign, so negative 62. That's a minus 62. You can write plus negative 62 if you want, but it's not a great idea with equations. You'll see why in a second. And then the 5 minus 9, that's 5 plus negative 9. Different, subtract, keep the sign of the larger. 9 minus 5 is 4. The 9 was larger, so negative 4. The 1x is unnecessary to write, so that's just x minus 62 equals negative 4. And then I see a minus 62, so we add 62 to both sides, giving us our answer. X equals, the 62's cancel. Negative 4 plus 62. Those are different. Subtract, sign of the larger. 62 minus 4 is 58. The larger is positive, so x is positive 58. So I want to write something that'll look a little weird. When I had the 1x minus 62 equals negative 4, some people would write that as x plus negative 62 equals negative 4. Now, there's nothing wrong with this. And in fact, you're doing exactly what your teacher suggested you do. Don't write subtraction, write add negatives. But here's the problem. When you try to figure out what to do to both sides, you'll see, oh, I see an addition, so I'm going to subtract on both sides. And then you see, oh, here's a 62, so I'm going to subtract 62 on both sides. That was not the correct step. We were supposed to add 62. So that was wrong. The actual correct step, you can say I'm subtracting still, because I see a plus. You can say, oh, okay, we're still going to subtract. We're not subtracting 62. This number right here is a negative 62, so that's what we're supposed to be subtracting. And it just looks weird, and most people never write it the correct way to begin with, because subtracting a negative 62 is really adding 62. So this is correct and would still give you x equals 58, not 50. Not 68, 58, there we go. But it just looks wacky, which is why I say that moving forward in classes, you generally don't write adding a negative. You just leave it as a subtraction. You see it hopefully 10 million times because you practice 50 million homework problems, right, everyone? That you just get used to, oh, and I see a minus, I know inherently that's adding a negative. Right. Next topic we had, so we did example 5. We were ratios and proportions. We said ratios are just fractions. We suggested when you're using your words, we suggested using your words to give an order. So if they're talking about apples and oranges, write apples over oranges so that you know the order to go in. You generally need to reduce these unless told otherwise. If they tell you not to reduce, then don't reduce, but that's rare they tell you that. Proportions are a ratio equal to another ratio. You cross multiply to solve or check. Remember, that's the top left times the bottom right and the top right times the bottom left. That's all it is. So let's just do a proportion. We've seen a decent amount of ratios. Example 6, we're going to solve. Now I know why I went back to blue this time. I did use it that time. Example 6, solve. And let's do 5 over 11 is equal to, I don't know, 45 over x. Now, if I put a number there for the x, let's say I wrote a 12 there, you would have to check this instead. You'd cross multiply and see if the product on the left is the same as the product on the right. Now, spoilers, if that x was a 12 in its place, it would not work, just as an FYI. But we were not asked to check, we were asked to solve, so we got to find the x. You may have been asked a word problem and you have to set this up. I might say something like, on Monday, a store sells 5 apples and 11 oranges. The store always sells proportional apples and oranges. On Tuesday, they sold 45 apples. How many oranges did they sell? So you'd write apples over oranges. For Monday, you'd write 5 over 11. For Tuesday, you'd write 45 over, well, we don't know the oranges, so x. And this would give you your equation. It's really not a crazy setup. So that's 5 times x, cross multiplying, equals 11 times 45. And you go, oh no, 11 times 45. Well, I mean, it's fine to use a calculator. You shouldn't need it, but we can. And we'll do that right here just for fun. If it ever loads. That's a calendar, not a calculator. See what happens when you rush, when you don't pay attention. 11 times 45. And we get 495. So that says 5x equals 495. That says 5 times x. So we divide both sides by 5. Oh, that's a big division. It's really close to 500 divided by 5, which would be 100. That's 1 less 5, so I bet the answer is 99. It's little tricks you can do with math like that. 495 divided by 5. Boom, 99. So x equals 99. All right. Geometry. We had perimeter, area, and volume. I am not going to go through every single one of these formulas. You've got a formula sheet for them, so you don't have to memorize everything. But you should have some basic ones memorized. To get the area of a rectangle, it's length times width. Perimeter is just add up all the sides. P for perimeter. For area, this is the measure of the inside. You have formulas for these. Perimeter is measured in feet, meters, inches, miles, etc. Area is measured in square feet, square meters, square inches, square miles, etc. And we had volume, which is the measure of the inside of a 3D object. Areas for 2D objects. And this is measured in cubics. So cubic feet, cubic meters, cubic inches, cubic miles, etc. It can also be cubic centimeters, cubic femtometers, and nanometers. All those things are possible. I'm not saying it's just these 4 things. I'm just trying to emphasize the squares, the cubes, and the linears. Linear being perimeter. And you know what? I spelled out the rest. I'll spell out perimeter. I don't want to be that lazy. You can write these using exponents as well. So a feet squared, meters squared, or feet cubed, meters cubed, which is typically how we do it. I just didn't want to have to take 2 hours to pull out the math palette since I'm avoiding writing on this one. I'm kind of discovering that Word likes to have a file either written only or typed only, and it's been crashing on me otherwise. All right, so example 7. Why am I trying to type that? Example 7. Black, please. Example 7. We're going to find, for A, find the perimeter and the area of this shape. That's not great looking. I want to make sure it looks rectangular, even with my poor artistic ability. We'll have this be 3 feet. We'll have this be 8 feet. Now, I'm only labeling those two sides, but because this is 3 and this is 8, the way rectangles work, we know that this one also has to be 8 feet, and this one also has to be 3 feet. So the perimeter, which you call P, is just the sum of the sides. 8 plus 3 plus 8 plus 3, which is 11, plus 8, which is 19, plus 3, which is 22. There is arguably a formula for this. We don't need it, though. And because it's perimeter, it's measured in feet because that was feet. The area is just length times width. So that's 3 feet times 8 feet, or 8 times 3, the order doesn't matter, which is 24 feet squared. For B, let's just do a cube. Let's not do a cube, a rectangular box, that is to say. So find V. And we're going to do. And we'll have this bottom be 10 inches. We'll have this side be 5 inches. And we'll have the vertical length be 4 inches. So the volume for a rectangular box is just the product of those three. There were more complicated volume formulas like for a cylinder or a pyramid, a cone. Again, you have access to all of those, a sphere as well. So the volume of a rectangular box is just the product of the 4, the 5, and the 10. It's the basic idea of volume. So we take 4 times 5 times 10 in any order you like, 10 times 5 times 4, 5 times 10 times 4. Those properties we mentioned earlier, associative and commutative, still apply. 4 times 5 is 20. 20 times 10 is going to be 200. But this is volume, so it's measured in cubic inches. Remember, you have to use drag down menus for those units sometimes. So it's important to understand which is which. That's example 7. Then finally, we had our scientific notation. The decimal place moves based on the exponent or vice versa. Then we said one way, if you're moving it left, the exponent's positive. You move it right, the exponent's negative. But then when you go from scientific to regular or regular to scientific, when you swap, everything's reversed. And it gets confusing trying to memorize that without doing 50 to 100 examples. So I gave you kind of a tip, and that was big numbers come from positive exponents. Small numbers come from negative exponents. Big being numbers 10 or larger, small being numbers less than 1. And when I say come from, it could also be the other way around. Positive exponents come from big numbers, negative exponents come from small numbers. So for example, 8, we're going to convert. And remember that in scientific notation, there's only one number in front of the decimal. That's the whole point. Example 8. We're just going to do 2 of these. Let's start out with 0.00005902. Got a bunch of zeros in front. This number is kind of annoying to write because you got to count them. 1, 2, 3, 4, 5, 6 zeros in front between the decimal and the 5. So that decimal place has to move behind the 5. It's got to go right. 1, 2, 3, 4, 5, 6, 7 times. That's 7 movements, so our exponent has to be a 7. So we write 5.9. Now you might say, oh, I don't need the trailing zeros, so I don't need the 0 after the 9, and you just write 5.92. That would be wrong. You need middleman zeros. So it's 5.902. You don't need zeros at the end. You don't need zeros in the front, but you need them in the middle in scientific notation. Then we have our times 10. Sometimes you do it with a dot, sometimes you do it with your x. And the exponent is either a 7 or a negative exponent. This was originally a small number, so this should be a negative exponent, so a negative 7. B, 2, 0, 0, 5, 0, 0, 0, 0, 0, 0, 0. So this is in standard notation, so we're going to switch it to scientific. I do not see a decimal originally, so it goes at the end. And we need to move this left to end up making a number that only has one decimal place in front of, or sorry, one digit in front of the decimal. So we need it to be after the 2 immediately. So it's got to go left 1, 2, 3, 4, 5, 6, 7, 8, 9. That got ugly. Let me start over. 1, 2, 3, 4, 5, 6. Have to move my hand. 7, 8, 9, 10 times. So this is going to be 2. And again, you won't need all these trailing zeros after the 5, but you will need the ones between the 2 and the 5. So 2005 with the decimal after the 2 times 10 to the, now I moved it left, so you might have that whole pattern memorized, but I prefer to say this is a big number. So this should be a positive exponent. We moved it left 10 times, so that's positive 10. We'll do one more of these since I didn't start with scientific notation. What if we had 3.9 times 10 to the negative 5? So we go to the side. We write our 3.9. And we're going to move this decimal left or right. Left or right. How do I know which? Well, this was a negative exponent. So our goal is to make a small number. If you move this thing right, 39, 390, 3,900, 39,000, that's going to make a big number. That would be the wrong way. We need to move this left 5 times. 1, 2, 3, 4, 5. There's some filler zeros needed, 1, 2, 3, 4 of them. So this would end up being 0.000039. Negative exponent, small number, everything agrees. I can't guarantee that you move the decimal the correct number of times with that big number, small exponent, sorry, big number, positive exponent, small number, negative exponent. You have to pay attention for that aspect. But it's a lot easier, in my opinion, than memorizing, oh, when you're going from standard to scientific, right gives us negative, left gives us positive. But when you're going from scientific to standard, everything flip-flops. It's a pain. It's frustrating. Can't tell you how many times I did that wrong growing up. Until I realized big numbers have positive exponents, small numbers have negative exponents. So that is everything. That is the entirety of the course, just a quick summary over 3 days. I hope that that has been helpful. I mean, that is a decent amount that we recovered. 4 pages worth of typing. It looks like 5 pages worth of typing. Yeah, 5 pages. Plus, I don't even know how many pages of work. And we didn't even do everything possible, 7 pages of work. We saved some of the more complicated problems by saving. I mean, we didn't do anything that was super crazy because I was trying to cram this entire course into 3 days, which I'm sure is fun for everybody. But I mean, it wasn't the first time you saw it. This was review. If anybody's even watching these review videos, I know the count on my others is still at 1 or 0. So hopefully I'm not posting this in vain. Hopefully somebody goes back and watches this. And I mean, it's here. So please watch it. Please study. Please do your homework. Please pay attention to the due dates. Please email me if you have any questions. Like I said, there's no grade change policy for this course because we are developmental. We were never going to get A's, B's, or C's to begin with. So that does not apply to this course. So Tuesday, Thursday, May 7th, by midnight, have your final done or you fail. My Monday, Wednesday class, Monday, May 11th, by midnight, have your final done or fail. This is it. This is what we've all been waiting for. So again, good luck to you. Make sure you abide by the rules. You have your 2 attempts. I wish you all the best of luck, not only in your finals for this class, but in the rest of your classes and in the rest of your lives. I know it's been a challenge with this very different format. Those of you who have been putting in the effort, I'm very happy that you have. I really appreciate that you're making an effort. I know not everybody has the ability to even do this course right now, so some of you are probably, thrown to the side because of that, because you might not have internet at home. You're not even seeing these videos. And I wish the situation wasn't what it was. We have to make the best of the situation. So please take care. Please work hard. Please do your best. And if you don't pass this course, pass it next time so that it doesn't end up costing you an arm and a leg. All right. It's been a pleasure. Email me if you have any questions. I'll see you in the future.